So we're now going to find volume of a known cross section. And so it's kind of a different thing, but this is flat, and then it pokes up and makes a square. So the base of it is flat. So this would be the base along here, and this would be the height. So we're going to do a whole bunch of squares. Notice it's a square, so as it gets wider, it gets taller. And so it's between these two functions. You can tell that these are f of x and g of x. So this function here is f of x, and this bottom function is g of x. So we're going to be looking at that difference, and we know that if my base is f of x minus g of x, my height must also be f of x minus g of x. So we're going to add up a bunch of these squares, and we're going to add up their area. So that's going to form this volume that's sitting on a flat surface poking out. So to find an area of a square, area equals the base, which would be the subtraction or the difference between the two functions, times the height, which is also the same because, again, it's a square. So really the area then is f of x minus g of x, and you're going to square that because you have both the dimensions the same. Now what we want to do is add up all these squares. So that should be familiar to you. When we add in calculus, we're going to take the volume of this is going to be equal to the integral. So we're going to add up all these squares from a to b, where a is the beginning and b is the end. And we're going to add up all those squares, which in this case was just f of x minus g of x squared. And then the thickness of each of these little guys right here is dx. So we have height times width. So that's what it's going to look like when it has a square. So the next one here we're going to look at, this is an isosceles right triangle. So that means this is a right angle. So that means the sides are the same. So it's sitting on the base. And we know that area of a triangle, so if I'm just trying to find one of these triangles, area is 1/2 the base, what it's sitting on, which happens to be f of x minus g of x. And we'll look at that in the picture here. Look at your two curves, f of x minus g of x. This is your base of the triangle, which is right here, and it's a subtraction of the distance between those two functions. And then we're going to multiply it by the height of that function, which would also be f of x minus g of x. And why is it the same? Well, because these two links on our triangle were the same. So if you look at this, it's very similar. It's almost like a square, but I'm taking half of it, because if you recall, you now have a triangle, which is half of that square. And this is, again, an isosceles triangle, so we're going to square that. So just like we did earlier, if I'm looking for volume, I'm going to add all these up from A to B, where I have to recognize where A and B are on my picture. It's a B, and it's going to be of the same 1/2 now of f of x minus g of x squared. And the thickness of each of these is going to be dx. And so what you can do if you'd like to, you could just pull this half out and leave it out in front if you'd like to. It doesn't matter. It's just a concept that could come out in front. And then you're going to have to square those or find a UDU to integrate. So we're going to do two additional shapes here. The next one that we're going to look at is an equilateral triangle. And if you recall about an equilateral triangle, all three sides are the same. So when I'm cutting it down here, okay, I'm still going to have that 1/2 base times height. And here's my base, which is sitting right here. So the area is 1/2. Let me show you that picture again. This is the base, which is sitting right here. So it's 1/2 the base, which again is the difference between those two curves. So I'm going to write that down. And then I need the height. Well, the height is that dashed line. If you remember much about an equilateral triangle, when we split it and we bisect this angle. So this is 60, that's 90. And if you recall, if this was 2, this was 1, and this was the square root of 3, so it's a square root of 3 multiplier. You did a lot of that in geometry at one point, I think. And if I'm looking at the height, okay, I need that value, which is square root of 3. Now I'm going to divide all this by 2. So I have this value to be 1. So it's a square root of 3 over 2. That was the relationship on that side of f of x minus g of x. So it's a square root of 3, but if you recall, okay, that's when this was in half. So that's where that 2 came from. All right, so I could clean this up just a little bit, and I would get the square root of 3 over 4 f of x minus g of x squared. So the 1/2 came from the formula 1/2 base, and the height of this thing is a square root of 3 over 2. That's the relationship on an equilateral triangle. Yes, cut in half to get the 30, 60, 90. So if I was going to find the volume, boy, I would integrate all of these. I could pull out the square root of 3 over 4 and just leave it as the constant outside. Find my a to b, which are the beginning and the end. And I would have, once again, this f of x minus g of x quantity squared. And notice that's being squared every single time. Now let's go ahead and now we're going to do a cross section that's a half circle. So if you recall, the area of a circle is pi r squared. Okay, and this is really not r, it's really that diameter. Okay, so we need to figure out what the radius would be. So if this length right here is this section here, you need just the radius of that. So it looks like you're going to have to cut that in half, so you're going to get half of the circle. So remember, this is a full circle. Half of the circle, so half of pi r would be f of x minus g of x. And what you need to do with that is take half of it, and then what you're going to have to do at the end there is square it. So the radius is half of this distance across. That's why I divided by 2. And then I'm going to square it. So I have a 2, a 4, because I'm squaring this. So I'm going to have pi over 8. And then I have f of x minus g of x squared. And that would be the volume of 1/2 circle, and I would then need to add up the volume of all of these. And I could pull the pi over 8 out in front, and I'm going to have an integral from a to b of f of x minus g of x quantity squared, and don't forget the thickness. dx is the thickness of each of those half circles that you're finding the sum of.